Welcome students to lesson 12, and today's date is Tuesday, September 22nd, 2020, and we're continuing with our studies of multiplicative comparisons, and today the title is Putting It All Together. Our learning target: I can determine the area of rectangular figures and apply their knowledge of multiplicative comparisons to find the area of figures. Our essential questions remain the same as they have been since the beginning of Unit 2. How can patterns within the number system help solve problems, and how are numbers related to each other? Our problem of the day: 28, 42, 84, and 35 are all multiples of what number? Explain how you know. Find 4 more multiples of this number. So we're going to pause just for a few minutes and give you an opportunity to think back on our previous lessons to see if you can determine the answer to this. So knowing your math facts or utilizing the multiplication table in the back of your math notebook, you should be able to figure out, well, what numbers for each of these can I use to multiply together to get this number? And then you're going to be finding the actual factors. So here for 28, I'm going to use my tool here. What numbers can I multiply together to get 28? So you can always start at 1. 1 times 28 is 28. And what other numbers can I use? Let's see, 2 times 14 is 28. Can I multiply 3 times any number to get 28? No, we can't. Let's go to 4 times 7 is 28. Okay? And there are no other numbers that you can multiply together to get 28. So we've got that for 28. So now we need to go to 42. Okay? So 42, what numbers can I multiply together to get 42? You always start out with 1 times 42 is 42. 2 times what number equals 42 is going to be 20. Let me erase this right here. It's going to be 21. 42. Can I multiply 3 times any number to get 42? Yes, we can. 3 times 14 is 42. And at this stage, you can use your calculator, guys, or use your multiplication table in the inside cover in the back of your composition notebook. The inside cover on the back of your composition notebook, there's a multiplication table to help you. Or you can use a calculator right now. Are there any other numbers that I can multiply together to get 42? And lastly, for 42, our last factor pair is going to be 6. Let me go back. 6 times 7. So we're doing all this, guys, so that we can find a number that is common to all of them. We're going to figure out what number is common to all of them, and then we'll know that that's going to be that all of these are multiples of that number. Okay, so we did 28, 42. Let's look at 84. So for 84, of course, you always start out with 1 times that number. 1 times 84, 84, and you've got 2 times 42, okay, equals the same. 3 times 28 equals 84. 4 times 21, 6 times 14, and 7 times 12. They all equals 84, okay? So I'm just going to bring this all the way down because all of these factor pairs equal 84. So lastly, 35. I'm looking for 35. So I'll do that over here. The number 35. You got 1 times 35 equals 35. Also, 5 times 7 equals 35. Okay? So let's take a look at them. We're going to figure out what number appears in all of these factor pairs. 7. 7. 7 and 7 is in each and every one of them. Okay, so you got, there's 14 in some of them, but not in all of them. There's a 2 in some of them, but not in all of them. But there is a 7 in each one of them. Okay, so that means that all of these numbers are multiples of 7. They're all multiples of the number 7. Find 4 more multiples of this number. Okay, so 4 more multiples of 7. When you're looking at when you know your math facts, or you're looking at the back of your composition notebook, when you're looking at your multiplication table, you'll also know that the additional ones are going to be 14, 21, 49, and 56. These are 4 more multiples of the number 7. So now if you go through and you do your math table again, you look at your math table, 1 times 7, 7, 2 times 7, 14, 3 times 7, 21, 4 times 7 is 28, 5 times 7, 35, 6 times 7, 42, 7 times 7, 49, 8 times 7, 56. So we've already got the 28, which is right here. The 42 is right here. 84 is further down. We got 35 is right here. And 42, 49, 56 are additional. Okay? So we're going to move on to our next slide, and here we've got area. So we're going to talk about area for a little bit. So let's take a look on this side. We've got area is the inside space within a boundary. So area is the shaded in blue area. It's the shaded in blue part of any figure. Okay? And what is the area of these rectangles? So you got 2 different rectangles right here. But the shaded in area, no matter what figure it is going to be considered area. It's the inside part of it. So the question, what is the area of these rectangles? So we're going to pause for a couple minutes and give you an opportunity to think about the answer for that one. And you can do your work inside of your math notebook. So you've had an opportunity to take a look at these 2 rectangles and to try to answer the question of what is the area of these rectangles. So for the first one, let's take a look. Again, we mentioned that the area is the inside space within the boundary of any shape, and in particular these 2 rectangles that we have right here. So we're actually going to go and we're going to count the inside. We're going to count the tiles on the inside. 1, 2, 3, 4, 5, 6, 7, 8. So these are square units. So the first one, it equals 8 square units. So the area equals 8 square units because it's the inside space. So now let's take a look at the second one down here. Okay, now remember, again, the inside part is the area. 1, 2, 3, 4, 5, 6, 7, 8. Same thing. The area is going to be 8 square units for that one too. So we have 8 square units for both of them. That is our answer. So we're going to move on to our next slide, and we've got the same rectangles drawn here though. We got different questions. How are the dimensions of these rectangles related? So how are the dimensions of these rectangles related? We've got two. We got one in blue, one in shaded in with a tan color. So we're going to pause for a second and give you an opportunity to, in just a minute, to look at it. And our example sentence here is the blue rectangle has a width that is blank, the width of the green rectangle. So I want you, when you think about this question, to just fill in the blank right here, okay? So you fill in the blank and think about our multiplicative comparison. Think about multiplicative comparisons and some of the terms that we use, such as double, twice, more than, as many as. So think about that while we pause. So using our example sentence right here, if you said that the blue rectangle has a width that is twice the width of the, and this color is actually tan right here, okay? So we're going to say tan. So the blue rectangle has a width that is twice the width of the tan rectangle. You would be correct. And let's take a look. How is that the case? Okay, so we're going to say that this is the width. This is the width over here. And this part right here is a width for this one. Okay, so when we count the width, we count both of these square units. 1 and 2. So the width here is 2. And the width down here, you just got 1 square unit. Okay, so the rectangle has a width that is twice. So 2 is 2 times as big as 1. 2 is 2 times as big as 1. The width of the tan rectangle. Explain how factors and multiples are related to area. We're going to pause our video for a minute, and I want you to, in your math notebook, just kind of go through and jot down whatever answers you think may work for this particular one. Explain how factors and multiples are related to area. So you're going to think about it for a few minutes, and I want you to go in and write them inside of write your answer in the notebook. Okay, so on this part, if you answer something along the lines of, we use factors to create the dimensions when we know the area, we use factors to create the dimensions when we know the area, or the area is a multiple of the factors. The area is a multiple of the factors. You will be correct. Okay, so moving on to our very next slide, perimeter. So we just talked about area, which now we know is the inside of a figure. And now perimeter is considered the boundary around the area. So perimeter is the boundary around an area. These rectangles have different perimeters. Even though they have the same area, they have different perimeters. So what I want you to do is to determine the perimeter of each of these rectangles. So try to determine the perimeter of each of these two rectangles. So we'll pause for a minute and let you be able to do that. And again, since the perimeter is the boundary around the area, we're going to be counting the outside of it. So we'll be counting the outside of it, starting with the one at the top. And we're counting the square units. Imagine that you're looking from over here. Imagine that on this side, you are standing on this side of the figure and you're looking this way. What do you see? 1, 2, 3, 4. You see 4 units. Okay, imagine that you're on this side and you're looking this way. How many do you see? 1, 2. Okay? And imagine that you're on this side and you're looking this way. How many units do you see? 1, 2, 3, 4. Same thing over here. Imagine on this side and you're looking this way. How many units do you see? 1 and 2. Okay? So when you counted all those up, then you have your perimeter. So we've got at the top, there's 1, 2, 3, 4. And at this side, there are 2. At the bottom, there are 4 total. And on this side, there are 2 total. So you've got 4 plus 2 is 6. Plus 4 is 10. Plus 2 more is 12. So 12 square units. So you got 12 square units. And this is going to be perimeter. Perimeter equals 12 square units on that one. We're going to do the same thing with the bottom one. Okay. So imagine we're going to do over here first. Imagine you're this side and you're looking at it from that side. What do you see? You've got 1, 2, 3, 4, 5, 6, 7, 8 total units on that side. And imagine that you're over here. How many do you see? There's just 1 right there. Okay. Imagine that we're down here and we're looking this way. We've got, I'll go this way, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total over here. There's 1 over here. There's 8 over here. We got 1 more side to go. 1. So now we need to add those up in order to define the perimeter for this one. So I'll just write that in the middle. So our perimeter is going to be equal to, we got 8 right here. 8 plus, there's 1 right here. 1 plus, and down here there are 8 more units, and over here there are 1. So we're going to add those up, and let's see what we get. 8 plus 1, 8 plus 8, 16, plus 1 more, 17, plus 1 more, 18. Okay, so we got 18 units over here. Okay, so this bottom one is 18, and this one is 12. Okay, 12 units. So that is our perimeter for both. 12 at the top and 18 at the bottom. So on to our next slide, we're going to be moving into more multiplicative area problems. And just moving on to our next one. Tommy's dad is teaching him how to make tables out of tiles. Tommy makes a small table that is 3 feet wide and 4 feet long. So 3 feet wide and 4 feet long. How many square foot tiles does he need to cover the top of the table? Okay, move the square tiles or use another visual model to support your answer. Okay, so for this one, we've got 4 feet wide, 3 feet long, and our question is over here. Okay, and he's teaching them how to make tables out of tiles, of course. So 4 feet wide, that means that this distance from here to here, 4 feet. And I'm sorry, this was the 3 feet right here. 3 feet wide. So let me go back and change my. Okay, so this side over here is 3 feet. And this is feet. And the length is 4 feet long. Okay, so from here all the way to here is 4 feet. All right, so that's the table that he has, and we've got a question to go along with it, of course. Just repeating it. How many square foot tiles does he need to cover the top of the table? So when we talk about covering the top of the table, we're talking about the area of that table. This is, if you look at it, it's in a rectangular shape. So the top is a rectangular shape. And we need to figure out basically the area of it. All right, so and right here it says the second question, how many feet of decorative border material will his dad need to cover the edges of the table? And that's going to be the outside of it. That's the same as our perimeter. So the second question is asking us about perimeter. And our next question, Tommy's dad is also making a table, but table is twice as long and twice as wide as Tommy's. Okay, so what is the combined area of both tables? All right, so we're going to kind of take a little bit of what we've learned so far to try to, I'll give you an opportunity to try to work on it. And so I want you to try to work on it inside of the slides right here, okay? So, and it gives us a little clue right here about how to actually make the rectangles that we actually need. So you can drop and drag right here as many as you want. So you can drop and drag as many tiles as you need to answer the questions. Okay, and in this section right here, you're actually just going to be typing the answer in, okay, in the bottom. And down here, you are dragging also, dropping and dragging. So the option of dropping and dragging, of course, you could do that. Another option that we practice is going up to the shapes. So you can go up to the shapes and you can get you a rectangle. So you click on shapes here and you pick your rectangle and you can actually build your own in here, okay? And in order to label it, remember, in order to label it, you're going to need to go up to the text box right up here. So you go to the text box and this, you can type in whatever you need to if you're typing on inside, or you can build a text box on the outside to type in answers, okay? So we're going to pause for a few minutes and I'll give you an opportunity to work on these. Okay, so here's our answer key. You've had an opportunity to work on it, so let's go in and compare your answers to it. And again, we've got the 3 feet wide, 4 feet long. Those are the numbers that we're working with. How many square foot tiles does he need to cover the top? So the top, of course, you get if you find an area of the top part, and it is 3 square units, 3 square feet wide. You've got 1, 2, 3. That's our width on this side, and our length again is going to be the 4. 1, 2, 3, 4. Okay, and so we're going to need that for our perimeter down here. So for our area, we are going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square foot tiles right here. So that's 12 square foot tiles in there. Okay. So if you drew the actual, you drew a square, you drew a rectangle, and you know that you need 4 equal parts from for the length. 1, 2, 3. You need 4 equal parts going down. So here's 1, 2, 3, and 4. And on this side, you need 3 equal parts. 1, 2, 3. So that's how I got this gridded rectangle. Okay. And when we move down to the bottom, how many feet of decorative border material will his dad need to cover the edges? So we talk about the edges of it, and this is where our numbers on the outside are going to come in. We're talking about the perimeter. So we got, again, 1, 2, 3, 4. We got 1, 2, 3 over here. It's going to be the same on this side. 2, 3 over here, and you got 4 over here. So we're going to add those all up. We got 4 plus 4 plus 3 plus 3. So 4 and 4 is 8. Plus 3 is 11. Plus 3 more. That's how we get our 14 right there. That's how we get our 14 feet. And that's for the exterior part. So at the bottom, we've got a table that is twice as long and twice as wide as the one up here. Okay, so you've got, remember we counted 1, 2, 3, 4 for our length. So this one, 1, 2, 3, 4, 5, 6, 7 is 8, because 4 times 2 is 8. That's twice as long. It's 8. And when we talk about our width, remember on our top one, the width was 3. And now we're going to double that. 4, 5, 6. So 3 times 2 is 6. Okay. So our area for this one, we're going to need to count them all up. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So you got 8 in each one. So 8 there, 8, 8, 8, 8, and 8. All right, so let's do our 8 is 8. 1, 2, 3, 4, 5, 6 times. 8 times 6, so you can do the repeated addition. Okay, which is 48 for this one. So it's 48 for this one. So our area down here is 48. And remember, our area up here was 12. So that's where we get the 48 plus the 12. And when we with the double one down here, and a total of 60 combined. So we're going to do something similar for our very next slide. And this one I want you to work on independently. Okay, so independently, you're going to work on the next slide. And I want you to work on it first, but I am going to tell you that our answer key, after you finish, you go to your next slide. I want you to check your answers, okay? And if you're having a lot of trouble with it, what I want you to do is just look at the answers first, and I want you to try to figure out, well, how did I come up with these answers? Okay? So that's your independent work going, and you can work on it on the actual slides. And on our very last slide here, our independent task, we worked on one together, and I want you to go back to the previous slide and work on that one. Now, those two slides actually came from page 99 in our binder. So if you feel more comfortable working inside of the actual math binder, you can go to page 99 and you will find this one, and you'll find that one in there, okay? Also, what I want you to do is go to Khan Academy. We have assigned area and perimeter videos for you. So I want you to watch those videos and take notes on the videos. As you watch them, take notes inside of your math notebook.